Welcome. In this video, we'll discuss container threat detection. Containerization is a software deployment process that bundles an application's code with all the files and libraries it needs to run on any infrastructure. In today's cybersecurity landscape, it's imperative to understand the potential risks and vulnerabilities associated with containerization. Container threat detection is a critical component in identifying and addressing such risks. Container threat detection is a powerful security feature that is included in the Security Command Center Premium tier. It provides continuous and comprehensive scanning of the node images of container-optimized OS, ensuring that any potential security threats are identified and addressed in a timely manner. The service utilizes advanced algorithms to quickly detect any runtime attacks by analyzing changes in remote access attempts. In addition, it provides alerts to users of common container attacks through the Security Command Center and cloud logging. The Container Threat Detection feature is designed to detect and identify a wide range of threats, including suspicious files and harmful plain text bash scripts. The service employs natural language processing (NLP) techniques to analyze and identify potentially harmful scripts, making it an extremely effective tool for securing container environments. Overall, the Container Threat Detection feature is an essential component of any container security strategy. It provides real-time threat detection, ensuring that any potential threats are addressed before they can cause damage to the system. With its advanced capabilities and comprehensive scanning, Container Threat Detection is a must-have for organizations that rely on container technology to support their business operations. So how exactly does Container Threat Detection work? For starters, Container threat detection uses what is known as detection instrumentation. This sophisticated technology collects detailed activity from the guest kernel and any executed bash scripts. When container threat detection detects an event, the event information, along with identifiers for the container, is sent via a user mode daemon set to a specialized detector service for in-depth analysis. Note that although the daemon set is designed to be diligent, it operates on a best effort basis. This means that if Kubernetes or the container runtime is delayed in delivering container information, that data might not be included in the reported findings. The core of the system is the detector service. It scrutinizes the events to decide whether something is just an anomaly or a potential security incident. One of the standout features of the container threat detection technology is the use of natural language processing to evaluate the contents of bash scripts, determining if they're just regular scripts or something malicious. If an incident is detected, the service records it as a finding within the Security Command Center. You can check out the details of any findings directly in the Security Command Center dashboard, where you can also conduct further investigations. Keep in mind, what you can see and do with these findings depends on the access roles you've been granted. Container threat detection includes a set of detectors, each with specific roles in identifying potential security breaches. The added binary executed detector is crucial in spotting any binary that is executed but wasn't part of the original container image. Such an occurrence could indicate unauthorized access or control, so it's vital for early threat detection. The added library loaded detector, similar to the binary detector, alerts if a library that was not in the original container image gets loaded. It's another key indicator of possible unauthorized code execution within the container. The malicious script executed detector employs advanced natural language processing to analyze executed bash scripts. It's designed to identify scripts that could be harmful, helping catch more sophisticated attacks. The malicious URL observed detector checks the argument list of running processes against a list of unsafe web resources maintained by the Google Safe Browsing service. Lastly, the reverse shell detector is particularly important. It identifies when a process starts with its input or output streams redirected to a remote connected socket. This can be a sign of an attacker seeking to control the workload remotely, a common tactic in advanced cyber attacks. Let's take a look at the system. When you activate Security Command Center Premium, Container Threat Detection is enabled by default, unless you choose to disable it during the activation process. If you need to enable or disable Container Threat Detection for your organization or project, you can do so on the Security Command Center Settings page. To access the Settings page, Click the navigation menu in the top left corner, then select Security from the list of services. Next, click the Settings icon that resembles a gear or tools at the top right of the screen. Cards representing each service appear. Locate the Container Threat Detection card and select Manage Settings. The Service Enablement page appears. On this page, identify the specific resource on which to enable the container threat detection. Threat detection can be enabled or disabled for a particular folder or a specific project. In the Service Enablement section, click the drop-down box for the chosen resource. Here you may enable or disable the detection. This option ensures that container threat detection becomes active for the chosen folder or project. Now we're ready to identify container threats. With Container Threat Detection enabled, we'll verify that it's functioning correctly within the Security Command Center by intentionally triggering detectors and checking for findings to ensure the system's security measures are active and effective. Before diving in, there's a crucial prerequisite. To effectively detect potential threats to your containers, it's essential that your clusters are running on a supported version of Google Kubernetes Engine. For detailed information on using a supported GKE version, please refer to the relevant documentation. So let's set up our testing environment. We'll be using the Google Cloud Console and Cloud Shell for this exercise. From the Google Console, select the project that contains the container you intend to use for this test. Next, click the icon for Activate Cloud Shell in the upper right corner. In the Cloud Shell, we'll set up the environment variables. We'll start with the environment variable for the zone our cluster is in. Type export zone equals, followed by the name of the zone. Next, set the variable for the project your container is in with export project equals, followed by project ID. And finally, define your cluster name with export cluster underscore name equals, followed by the cluster name. With these variables set, you're now ready to begin testing the container threat detection detectors. Now we will trigger an added binary executed finding in the container threat detection. This process involves adding and executing a binary in your container, which is a critical test to ensure your security measures are effectively detecting unexpected changes in your environment. We'll start by understanding the rationale behind this test. We'll deploy the latest Ubuntu 18.04 image, copy binaries to a different location in the container, and then execute it. The execution of this binary will be flagged as unexpected because this copy wasn't part of the original container image. First, let's make sure we have access to the cluster control plane by entering the following command in Cloud Shell. Now, the crucial part. Dropping and executing the binary. To do this, paste the command at the prompt. This command sets a unique tag based on the current date and time. It then deploys a container with the Ubuntu 18.04 image, copies binaries to tag, and executes it. Executing this test should generate an added binary executed finding. Next, we'll check for this finding in the Security Command Center. In this section, we'll focus on reviewing container threat detection findings in the Security Command Center. This is a vital step in monitoring and responding to security issues within your Google Cloud environment. Let's dive into the steps needed to effectively use this feature. Navigate to the Security Command Center Findings page in the Google Cloud Console. Confirm you are viewing your Google Cloud project or organization. This ensures you're viewing the findings relevant to your specific environment. Next, in the Quick Filters section, look for the Source Display Name subsection. Here, select Container Threat Detection. This filter will narrow down the findings to those specifically detected by the Container Threat Detection service. To delve into the details of a specific finding, click on the finding name listed under the Category column. This action will expand the Finding Details pane, providing you with a wealth of information organized into various sections. You will see sections like What was detected, which includes information about the security issue that was detected, complete with an AI-generated summary of the issue. The Affected Resource section will give you details about where the issue was detected. If your team has added any security marks to the finding, they will be under the Security Marks section. Furthermore, the Detection Service section provides information about the Security Command Center service that detected the issue, such as container threat detection and details about the finding itself. Finally, for a comprehensive view of the finding in a structured format, you can click on the JSON tab. This tab will display the complete JSON structuring of the finding, which can be particularly useful for technical analysis and record keeping. So, reviewing container threat detection findings in the Security Command Center is a crucial step in maintaining the security integrity of your Google Cloud environment. By following these steps, you can effectively monitor, analyze, and respond to security issues detected within your infrastructure. Thanks for watching this training on Google's container threat detection. We'll see you in the next video.